Okay, so now we made it to the last section of this chapter, and we're going to talk about why create functions. I know it's been a long chapter, but it's necessary. We still got another chapter to go on functions. But take the time to really learn these small nuances. Practice, practice, practice. I'm telling you, get your head wrapped around those concepts. The best way to do it is by doing it. So if you are new to this channel and you're not a part of the cohort, the curriculum textbook is in the description. Click it, it's free. You have access to it. You can follow along. So let's get into the curriculum. Why create functions? After wading through all of the new syntax necessary to create a function, you might be asking yourself, why would I ever want to do this? Good question. We have a few answers. Functions reduce repetition. Like loops, functions help us keep our code dry, and dry means do not repeat yourself. When we need to repeat the same basic task in multiple parts of a program, a function will allow us to package up that task into a neat, reusable form. Loops enable the same task to be repeated many times in succession, while functions enable the same task to be repeated in different portions of a program. Now, what I'm saying, go back to the house analogy with your HVAC system. Understand that it's to create that HVAC system, you need your central unit, your furnace, and your hot water heater. Well, what if you had to, back in the day when they had to heat a house, they would have to cut wood. They would have to burn that wood just to keep the house warm. Now you have a furnace that does it. So that's what we mean. Functions make your code more readable. Placing a piece of functionality within a function allows us to put a name on that functionality. Consider a palindrome example. One way to write the function is like this. And I hope you are practicing that. This is something good to learn. Practice this, work with this, learn how to use this, because this is the foundation of writing a function. While the variable name reverse is descriptive, giving us a sense of what is going on with this for loop, the function becomes even more readable when we break out the reverse behavior into a separate function, like this right here. This is called refactoring right here. You start off like this, then you refactor it to make it even more efficient. Aside from following the principles that functions should do only one thing, the logic with its palindrome is more clear and self-descriptive. The function itself says a string is a palindrome if it is equal to its reverse. To draw this same conclusion from the example above without a reverse function, we are required to analyze more of the program logic. Functions reduce complexity. Large programs can be broken down into smaller parts using functions. Imagine a car built out of a single large piece of metal. Were such a car to break down, diagnosing the problem would be difficult and fixing it nearly impossible. The mechanic will have to determine where the issue was, then cut apart the bad portion, creating a custom-made replacement portion, and weld it into place. The complexity of this situation becomes much less when a car is made up of a lot of small parts, each of which can be tested and replaced individually. The same thing happens with code. While there are many other organizational units for programs, including modules, files, and packages, functions are the most basic and universal organizational tool. Functions enable code sharing. encapsulation or encapsulating. So we talked about encapsulation. So encapsulating behavior within a function makes it easy to reuse that code within a program. But it also allows you to share that behavior across files and even different projects. This becomes critically important when you start working on bigger programs that consist of a large number of files. You will explore this idea in module chapter. So we'll be teaching you this. Functions save millions of lives every day. Okay, not really. But the point is, functions are incredibly powerful tools that you will come to appreciate and find indispensable. Ask a professional programmer if they could do their job without functions. The answer is no. And the answer will be an emphatic no. While functions may seem attractive and difficult to learn, let me read that again. While functions may seem abstract and difficult to learn at first, repeated practice will lead to mastery. We promise that your work will be worth it. Okay, so we made it to the end of this section and the end of this chapter. Functions are very important. You're going to use them throughout the rest of your career. So that's why it's so important to take the time to understand them now. Remember, I said it's easier to plant a tree than it is. It's easier to plant seeds than it is to plant a tree. And what I'm saying by that is it's easier to learn about these functions now as we break it down in little small pieces than to later on get thrown into the mix on functions and you're overwhelmed, and next thing you know it, you're feeling anxiety. Trust me, I've been there. I didn't go through any courses. I was self-taught. I was all over the place, and I got a job becoming a developer, not even understanding JavaScript. And I struggled for years because when it was thrown at me, I had to figure out how to learn it. It was like planting a tree. It was so hard. But then over the years, because I stuck with it, I was able to really get a grasp of it and got better at it. But I want to make life a lot easier for you. This is why I'm making these videos, because I want to make sure you can avoid some of the pitfalls and the struggles that I faced. So that's the end of this video, the end of the chapter. And remember, the more you do, the more you improve. See you in the next chapter.